All right, so we can restrict the cosine function so that it does end up passing the horizontal line test. And something we talked about in the past is that when a function is only increasing or only decreasing, it will always have an inverse because it will always pass the horizontal line test, therefore always be 1 to 1. Okay? So what we want to do, we recognize that the cosine function, the sine function, it oscillates back and forth, up and down, right? Okay? So there are y values that get repeated a lot. Well, if we can start to recognize an interval in which we can kind of chop that thing up so that it's only increasing or it's only decreasing, that would be a nice thing to do. And there's a lot of places that it's only increasing, and there's a lot of places that's only decreasing. If I look between any two consecutive maximums and minimums, so maybe that maximum there and that minimum, would you say it's only decreasing there? And then you can come over here and say, well, it's only decreasing there. It's only decreasing there. Okay? So that decreasing repeats, right? And the same thing happens for increasing. We say from negative pi to 0, it's increasing. From pi to 2 pi, it's increasing. From 3 pi to 4 pi, it's just increasing. So we got a lot of places where we can kind of cut this thing up and see that it's only increasing or decreasing in those places. The most logical, the most natural place is to take your cosine function and restrict it between 0 and pi. When we do that, we get that blue curve, okay? And that blue curve is the restricted portion that we want to look at, okay? So that there is going to pass the horizontal line test. Is that okay with everybody? Okay. Now, that domain then, okay, for the restricted cosine, the domain is 0 to what? 0 to pi. It's just the x values, right? And the range, what are you seeing that the range would have been here? Yeah, negative 1 to 1. Okay? So if we look at that restricted cosine, it should have an inverse. And inverses are just reflections across what line? Y equals x. So if I type in y equals x here, just to kind of bring back what we've talked about in college algebra, if I take that line, or that curve, and reflect across that line, it gives me that, which that red curve then is the inverse of the restricted cosine. Does that make sense? Okay. So I'm going to kind of put that over here in the yellow so you don't have a whole lot of like overlap and confusion. So in the yellow, stop doing that. All right, so we've got cosine inverse of x, and that would be essentially the red curve that I see over here. Okay, so you see that these two curves are a little bit different. What this means to me, if I've got a point on this curve that is an a comma b, then I should have a point on this curve that is a what? B comma a. And what that tells us then is that this domain becomes the range over here, and this range becomes the domain. And you can see that, you can kind of verify that to yourself. The x values that the green curve is graphed between are negative 1 and positive 1, so there's your domain. And the range, the y values that your graph is graphed on, is 0 to pi, right? Okay. So when we deal with the cosine inverse, and this is the cosine inverse, okay, or if you want to call it the arc cosine, okay, the input values can only be between negative 1 and 1, and that's something to think about. And the output values are only between 0 and pi. So if we're thinking about unit circle stuff, because you can approach this stuff using unit circle kind of a mentality, or use that as kind of a visual aid for you. Because remember what we're doing with the unit circle. Initially, I gave you an angle for the cosine or sine, and then you spit off one of these, right? Now I'm telling you, okay, I want either the cosine inverse, okay, so then you'd be looking at the x values on here, and then work your way back into the circle and try to find the angle. Does that make sense? Okay. Or I give you the sine inverse, so now you'd be looking at the y value. Where is it 1/2? And then see, okay, what angle work back on the inside of the circle? What angle is that? Okay. So the arc sine, arc cosine, they're giving you angles back. So these functions, just going to reiterate that again. These functions, the sine, cosine, and tangent, are going to give you the ordered pair. Okay, going to give you the x's and the y's, respectively. The inverse functions are going to use an input of one of these ordered pair, one of these coordinates, and the output, what you're looking for, would be the angle that's attached to them. Okay, the cosine inverse only has a domain between an output between 0 and pi. So when I look at plugging numbers in between -1 and +1 for the cosine, you're only going to get values back that are between 0 and pi. So you're only going to get things back between, like pi over 6, pi over 4, pi over 3, maybe 2 pi over 3, 3 pi over 4, 5 pi over 6, or pi. You will never type in cosine inverse of something and get 11 pi over 6 back, because 11 pi over 6 is in this quadrant here, right? And that's beyond our range, okay? 11 pi over 6 is beyond that number right there. Does that make sense to everybody? Okay. Same thing for the sine and the sine and the tangent. Sine, though, is only going to give back answers between -pi over 2 and +pi over 2. So the sine is only going to be looking at that portion of the unit circle if we're going to use the unit circle mentality. Is that okay with everybody? Okay. So that's your, like I said, that's your arc cosine. Let's real quick investigate what the tangent inverse looks like. Okay, so graphing over here, we'll just do the tangent function. And just like anything else with the tangent function, we just want an interval in which this thing is increasing. Would you agree that each one of these red curves is just strictly increasing from left to right? Does it ever start to dip down and start repeating y values inside one set of asymptotes? If I just look at, x equals pi over 2 and x equals -pi over 2, if I just look at those asymptotes, does this red curve in between those asymptotes ever start to decrease? No. Okay. So there's your interval. All we need for the tangent, to find the tangent inverse, is to take the tangent of x between -pi over 2 and pi over 2. So we're really just going to kind of look at that initial fundamental period that we've been dealing with, and that thing will have an inverse. That thing passes the horizontal line test. Okay? So reflect that over the line y equals x. And if I reflect it over the line y equals x, it's going to look like this. Okay, looks like that orange curve. And hopefully this makes sense to you if I look at, let's see here. Just choose a point on here and ask that to show me the name and value. So at that point, so what I'm going to do over here is I'm going to say that I want to plot the y value of A, comma, the x value of A, and it gives me that point right there. And that shows up on the curve. So what I did is I flip-flopped these ordered pairs, these coordinates, and it showed up on the curve, right? So this is like an A, comma, B, and this becomes B, comma, A. Is that okay with everybody? Okay. So it is a reflection over the line y equals x. What is the domain over here? What are the x values that we looked at? Yeah. And the range, then what's your range? What's the smallest y value you can come up with? So I guess largest negative y value. Negative infinity, right? What's the largest positive y value? Positive infinity. So my range is all real numbers. Okay? So when I come over here to the inverse, the domain of my inverse is what? All real numbers. Okay? The range then is negative pi over 2 to pi over 2. Okay? So this is the arctangent or the tangent inverse. When you're dealing with those guys, you can actually, that one's a little bit different than any other one. You can input any real number that you want to, and you're going to get something back. Okay? But that something you get back is always going to be between negative 1.57 and 1.57. Okay? Negative pi over 2 and positive pi over 2. Does that make sense? Tomorrow, so now that we got these graphs down, we understand what they look like. Tomorrow, we'll actually work with evaluating some of the problems that you see in 6.5. Okay? I have opened 6.5, due sometime next week. If you feel comfortable with it, you can start. What I want to kind of point out to you is that yesterday we did some examples. Well, we'll talk about tomorrow. I hate these 2 hour lists.
We only have one.
Hey, you too.